Solve the equation y prime plus 1 over t y equals cosine t where t is greater than 0. First, find the integrating factor. So that means mu of t here would be equal to e raised to the antiderivative of 1 over t dt. And when you anti-differentiate 1 over t, you get e raised to the ln of t. Because t is greater than 0, you don't need the absolute value bars there. And then because e and ln are inverse functions, you can just bring the t down like this. So that means that t is what we're going to multiply every term by. So let's do that. We're going to have ty prime plus t times 1 over ty, and this is equal to t cosine t. So multiply everything by the integrating factor. Simplify, so ty prime, because as you see, t is greater than 0, it basically cancel off the t anyway. So it's going to be just y is equal to t cosine t. On the left side, ty prime plus y, that has to come from doing the product rule on the following, t and y. Because if you did that, you would have the derivative of t, which is 1, you would copy the y, plus t times the derivative of y, which would be y prime. So that's that. And on the right side, we have t cosine t. From here, we can just anti-differentiate both sides. So when you do that, you're going to have ty, that gets isolated. But on the right side, you're going to have the antiderivative of t cosine t dt. And if you like, you can add a constant c, little k c. Then either you divide by t or you multiply by t to the negative first. You end up with y is equal to t to the negative first. Some people would write it antiderivative t cosine t dt plus t to the negative first. For now, I'll write it this way, times c. Anti-differentiating t cosine t, let's do that. So t cosine t is a product of two functions, t and cosine t. So you can use parts, which means you're going to use isolate. So in this case, no inverse, no logarithmic, but an algebraic one. So you can set u equal to t. That means du is equal to dt. You can set, let's see, dv equal to cosine t dt. That means after anti-differentiating that part, you're going to have that v is equal to sine of t. So it's going to be t sine t. And here I meant to write the dt. That goes away when you need to differentiate. So t sine t, okay, integral of v du. So that would be, let's see, sine t dt. But that's just t sine t. What's the function whose derivative is negative sine? That's cosine. So you're going to have plus cosine t. So now go back over here. You're going to have y is equal to t to the negative first. And replace the integral with t sine t plus cosine t plus t to the negative first times c. And lastly, perhaps more conventionally, we would write this as y is equal to the following. Take the t to the negative first, distribute it to each term inside the brackets. That means this t here will cancel with the t to the negative first, leaving sine t plus cosine t times t to the negative first is going to be cosine t over t. And then you can write that as plus c over t. And that's the solution. In terms of c, then you can plug in different values of c to get different curves. So see if you like,